Children are the highest consumers of added sugar, even as high sugar diets have been linked to health effects like obesity and heart disease, and even impaired memory function. However, this is known about how high sugar consumption during childhood affects development. But what does science say about the impact of excessive sugar intake on a child's developing body and mind? Kids these days are consuming more sugar than ever, often in the form of fructose, which is sugar derived from honey and fruit. Sound innocent enough, but too much fructose can be causing damage to children's developing brains, something that is far from sweet. When fructose is consumed right from the source, that's not the real issue. They are fiber and enzymes that have a nutritional value. But when it's used to sweeten other foods, the heavy sugar concentration is more difficult for the liver to process more so than the cane sugar. In addition, fructose doesn't trigger insulin release as a glucose does. This confuses the brain but not signaling that the person is full after consuming fructose-containing foods and beverage. Babies are more likely to overeat, leading to weight gain. High fructose corn syrup is used to sweeten soft drinks and is found in a wide variety of processed foods, including salad, jams, jellies, ice cream. The UCLA scientists conducted a study to learn the effects of fructose in rats' brain. In a rat's brain to assess how fructose could alter the human brain. 200 babies' genes that help regulate memory and learning were identified. It was found that fructose affected these genes, potentially contributing to a variety of brain disease. Previous research found that fructose damaged consumption between brain cells and increased toxic molecules in the brain, and that a long-term high fructose diet diminished the brain's ability to learn. However, a suitable amount of glucose is indispensable for the immune system, but its evaluated amount leads to excessive pro-inflammatory cytokines production. Foods that significantly rise blood sugar, such as those high in added sugars, including the production of inflammatory proteins like tumors necrosis alpha, C-reaction proteins, and the interleukin 6. All of which negatively affects immune function. What's more, having high blood sugar levels may inhibit the response of neutrophils and phagocytes, two types of immune cells that help protect against infections. Evidence from epidemiologic and preclinical studies demonstrates that excess sugar consumption can lead to increased risk of developing cancer in the future for children, independent of association between sugar and obesity. The mechanistic preclinical studies in multiple cancers show that high sucrose or high fructose diet activates several mechanistic pathways, including inflammation, glucose, and lipid metabolic pathway. Preclinical studies using mouse models show increased tumor burden, early onset, and a greater prevalence of various cancers in a mice fed high sucrose or a high fructose diet, compared with the isocaloric starch diet. New research led by University of Georgia faculty member in collaboration with the University of Southern California Research Group has shown in the rodent model daily consumption of a sugar-sweetened beverage during childhood improved performance on the learning and the memory test during adulthood. The group further showed that changing the bacteria in the gut may be the key to the sugar-induced memory impairment. Early life sugar increased parabacteroides levels. The higher the level of parabacteroides, the worse the animal didn't last, said Emily Knoll, assistant professor at the UGL College of Family and Consumer Science. We found that the bacteria alone was sufficient to impair memory in the same way as sugar, but it also impaired other types of memory function as well. The fructose component of sugar and HFCS is metabolized primarily by the liver, while the glucose from sugar and starch is metabolized by every cell in the body. Consuming sugar, fructose and glucose means more work for the liver than if you consume the same number of calories of starch. And if your baby takes the sugar in a liquid form, so that fruit juices, the fructose and glucose will hit the liver more quickly than if you consume them. Say an apple. The speed with which the liver has to do its works will also affect how it metabolizes the fructose and glucose. In animals, or at least in a laboratory rats and mice, it's clear that if the fructose hits the liver in sufficient quantity, with a sufficient speed, the liver will convert much of it to fat. This apparently induces a condition known as insulin resistance, which is now considered a fundamental problem on obesity, the underlying defect in heart disease and in the type of diabetes, type 2. This is common to obese and overweight individuals. It may also be underlying defect in many cancers.